Good afternoon everyone, I am Mr. Ish. Thank you for joining me for this video here where we're discussing the difference between empirical formula and a molecular formula. What is a good difference between the two specific terms? Imagine a metal and an oxygen combine and they react, they form a compound always in the form or the most basic form of MO2. But the actual compound you have is really this M2O4, where M stands for metal, O for oxygen. This right here represents your empirical formula. I'm just abbreviating EF. This here represents your molecular formula because you have a certain compound X, and you're trying to determine its molecular formula. This is exactly what it is, because that compound which you have, compound X, has 2 metal atoms and 4 oxygen atoms. If you were to determine the molecular weight of this, it would be accurate because you would be looking at the molecular formula. The empirical formula would just represent the molecular formula, but in its most basic defined ratio, or in its most simplest of forms, where everything is simplified down to the most basic of ratios. Here you have 1 metal for 2 oxygens, here you have 2 metals for 4 oxygens, but see, this right here is a simplified form of that. The simplified form with the fixed defined ratios is your empirical formula. The actuality of what you really are holding is your molecular formula. And given that as a difference between the two terms, let's look at 2 questions in this particular video. Our question is this: we have a certain compound X which is by mass percent composition. Mass percent composition, 58.8% carbon. It is 7.03% hydrogen and 37.17% oxygen. The molecular mass of this compound X we have is 86.1 grams per mole. We have to find the empirical formula and the molecular formula. The first thing you want to do is determine the empirical formula, and everything over here gives it away. You have 55.8% by mass percent of carbon in that compound X. You divide this by 12, which is a molar mass of carbon. For hydrogen, what you have is 7.03%, and you divide that by 1. I'm just rounding these numbers down. The molar mass of hydrogen is just 1. For oxygen, this compound is 37.1% oxygen, and you divide that by 16. When you do this, you get a bunch of numbers, and we have to determine what those numbers are. For carbon, you do 55.8 divided by 12, you get 4.65. So you're determining here a ratio in terms of carbon for this compound X is 4.65. Here you'll have 7.03, which we can just write as 7.03. Here you'll do 37.17 divided by 16 for oxygen. You have 2.323. Now you find the smallest one of these, which is oxygen. You divide it by exactly what it is, and you'll get 1. And you'll divide everything else now by that, and you'll see everything will come out here, and it will help you here in the determination of the empirical formula. When you do 4.65 divided by this, you'll get 2. When you do 7.03 divided by that, you'll get here a 3. What does that tell you? It tells you in terms of the empirical formula, the most basic defined ratio formula for your compound X is this. You have 2 carbon atoms, you have 3 hydrogens, and you have 1 oxygen. But this is your empirical formula. It's not your actual formula, your molecular formula. You have to determine both. We've done this, you have to determine this. You're given that the molar mass is 86.1. If you were to determine the molar mass of this, it'll tell you by how many multiples off you are. Like how many multiples away is this from the molecular formula. And a good distinction between empirical and molecular formula is, based on the empirical formula, the molecular formula is a certain number of multiples of that empirical formula. Just do this. You have 2 carbons times 12, which is a molar mass, plus 3 for hydrogen, plus 16 for oxygen. You're having here a molar mass of this compound, 43 grams per mole. When you look at this, 43 versus this, you're 2 multiples away. So all you have to do is just multiply this by 2. You'll have C4H6O2, and that right here would be your molecular formula. This molecular formula for the compound X has 4 carbons, 6 hydrogens, and 2 oxygens. But in its most simplified empirical form, you have 2 carbons, 3 hydrogens, and 1 oxygen. This right here is your empirical formula. This right here is your molecular formula, and this question has been completed. Let's look at this question. The second question, we have a compound X which is made up of nitrogen and chlorine, and who knows what ratio? Nitrogen and chlorine. So it's a nitrogen chloride compound. We have 0.77 grams of nitrogen which react with chlorine. We don't know how much it's reacting with chlorine, but it forms 6.61 grams of this nitrogen chloride compound. We have to find the empirical formula of that compound, and how would you go about doing that? Start with a basic reaction, nitrogen plus chlorine, to give you some sort of a nitrogen chloride compound. You know you have 0.77 grams of this and you're generating 6.61 grams of that. How do you know how much chlorine is reacting? Well, think about the law of conservation of matter. Matter cannot be created or destroyed. You can only convert it from one form to another. If you're starting here with 0.77 plus a certain amount, you should end up with exactly that amount. You cannot create it out of scratch, but what you can do is 6.61 minus 0.77. You can get here a value 5.84. These two in their combination should equal in terms of mass exactly what you have in terms of a product. So the law of conservation of mass or matter helps you out in determining the chlorine. Now what do you do about this? You determine the number of moles. The number of moles will help you determine the ratios that are involved. For nitrogen, you have 0.77 divided by 14, the molar mass of nitrogen. For chlorine, you have 5.84 grams divided by 35.5 grams per mole. And you can determine what the values are here. For nitrogen, you have 0.77 divided by 14. You get here a 0.055. For chlorine, you do 5.84 divided by 35.5 and you get 0.1645. This is a smaller number, so you'll divide everything by that smaller number and see what happens. Here you get 1, here you end up getting 3. So it tells you there are 3 chlorine atoms reacting with 1 nitrogen. So the empirical formula would be NCl3. Then your compound, in terms of the empirical status, would be nitrogen trichloride. Now the molecular formula would be a certain multiple of it. You would have to multiply by a certain multiple, and if you did that, you would get your molecular formula. It could be N2Cl5, who knows what it is, but you need to know the number of multiples involved as a difference in terms of the ratio between your empirical to molecular formula to give you exactly the molecular formula. But this question has been done and you saw how it was done. The law of conservation of matter or mass was perhaps the most important concept to understand here. And that's it. Thank you for watching. Have a good day.